Okay, so the ratio in which they will react is 2:3. Now, regarding ammonium chloride is expensive, but also apart from being expensive, it will sublime. It will sublime. So, and but this is cheap, so we can take lots of calcium hydroxide. This is also called as slaked lime. This is called slaked lime. So we can take lots of slaked lime. This is cheap. So why do we, sometimes in the question it comes that why do we take more calcium hydroxide? Why not take more ammonium chloride? So we say that ammonium chloride sublimes. So the question also comes that if it's sublimed, then we should take more of ammonium chloride. No, to compensate for loss due to sublimation, we take more slaked lime. So for the reaction to continue, we can take any one of them as higher. Now, let us look at the uh, reaction for the laboratory preparation. First of all, you have to go for a round bottom flask. So when you take a round bottom flask, now we can take the round bottom flask in this direction also. Okay, but we will not take the flask in this position or this layout. We will place it slightly tilted. So that means we will take it as tilted. So this is how your flask will be tilted, and we'll position it with the help of a stand. We'll fix it so that it doesn't move, and at the bottom what we'll do is we'll keep a burner, and inside it we will place ammonium chloride and calcium hydroxide. So these are here, these are placed here, but usually they will not react just like that. It will look like a mixture. So what is required is we need to heat it. So once we heat it, what will happen is, once we heat it, this will form the ammonia, but along with ammonia there will be vapor. So we will pass it to pass it to a chamber here, where we'll keep lots of quicklime. Quicklime. What is quicklime? Calcium oxide. And this we will connect it to so this is basically the experiment, and this is where we'll collect the ammonia. Now why why the question comes is, first of all, why flask is tilted, and secondly, why take calcium oxide as a drying agent? Because why we need a drying agent? Because when you are going to heat this, then ammonia is going to get produced, but along with ammonia, what will go down here is water vapor. What will go down is water vapor. Now, if this flask is straight and not tilted, what will happen is the water vapor, the hot water vapor that is formed, will again trickle down. So, if it is in this position, then once the water vapor rises, it will again start trickling down the walls, the boundaries of the flask. And this can, due to this, your flask can crack. So, that is the reason that we take the flask in a tilted position. Okay. Now, regarding the use of calcium oxide, the question is, why take calcium oxide? Why not say concentrated sulfuric acid? Why not concentrated sulfuric acid? Or why not phosphorus pentoxide? Now remember that these two are what? Any oxide of non-metals, any oxide of non-metal are usually what? Acidic. So you have a base here and these are acid here. So they will react. So to avoid the reaction, what we do is we use another base. So calcium is a metal. So the oxide of a metal is base. So that is why they will not react. So this is the reason, or this is the answer for these two. Now, when we are collecting ammonia here, then how is the collection done? So this is also another important point here. Collection of ammonia. So ammonia is collected. It is collected by downward displacement of air. Ammonia is lighter than air. So what will happen? Ammonia will always have the tendency to go up. So that is why we collect it by downward displacement of air. And another way is because of its very high solubility in water. So we can collect it in water also. So these are the two points which are very important regarding collection of ammonia. In this experiment, you have seen that we have collected ammonia by downward displacement of air. Let us continue. Can we take anything else apart from this salt of ammonium that we have taken? When we talk about ammonium chloride, this is what is usually used for preparation of ammonia. But there are other salts of ammonium also, like for example, ammonium nitrate. We don't take ammonium nitrate. Okay, we don't take ammonium nitrate for preparation of ammonia. Why? Because the reaction is explosive in nature. And second, due to heat, ammonium nitrate decomposes. So that is one of the reasons that we don't take ammonium nitrate. Now let us come to another method. What are the other methods? We have seen lab preparation we can do with any salt like ammonium chloride and react it with say calcium hydroxide. We don't choose sodium hydroxide or potassium hydroxide because of its nature of deliquescent. Now, another method of preparation is with metal nitride. This is N3- valency. Okay. So how? For example, we take say magnesium and nitride, then by cross method we get magnesium nitride. If we react it with hot water, we pass it through hot water, then what will you get? When you pass it through hot water, we'll get ammonia and the hydroxide of magnesium. So magnesium hydroxide. Now you balance it. So we have how much? Magnesium 3. So we can write magnesium 3 here. This is the metal balance. Then nitride N2 here. So we can write N2 here. Then look at oxygen. Oxygen is here. There is 2 into 3, 6. So we can write here 6. Now look at hydrogen. Hydrogen is 6 to the 12. 2 3s are 6 and 3 2s are 6. So 6 plus 6, 12. So this is balance. So this is how we can react with metal nitride, or there's one more way. We can use aluminum nitride also. So aluminum is 3 plus and nitride is 3 minus. So when we will do cross, we'll get AlN. So we can use aluminum nitride with hot water also to produce ammonia. And what we will get is aluminum hydroxide. So valency of aluminum is 3. So 3 will come here. So if we balance it, look at aluminum 1, nitrogen 1, oxygen 3, but oxygen here 1. So balance it. Then hydrogen 3 plus 3, 6. So 3 into 2, 6. So this is balance. So this is the one of the way this another method for preparation of ammonia using metal nitrides. But we don't use this. We don't use this technique because it is very expensive, very costly. This is very costly. Metal nitrides are very costly. So this is the reason that we do not use metal nitrides. Now, very quickly, let us go through the collection of, or you can say, preparation of the aqueous ammonia, because we must agree here that in the book it is mentioned that if it's a ammonia, then they do not agree that this is a base. But moment you make the aqueous solution of ammonia, then what do we get? Ammonium hydroxide. So this, if you in aqueous solution, what is it? NH4 plus and OH minus. That means there is OH minus ion. So we can say that due to it having OH minus ion, so we can say that ammonium hydroxide is base or basic in nature. So how do we create the aqueous solution of ammonia? So to prepare the aqueous solution, this method is very similar to, or almost the same as the preparation of HCl acid. From one of my previous recording, you must have noticed that when we prepared HCl gas, because it is very highly soluble in water, very highly soluble in water, so we kept water in a trough and we passed HCl gas. But because the rate at which the HCl is generated and the rate of absorption is so high, that we had to change this to an inverted funnel. So on the same lines here also, collection of ammonia to create the aqueous solution of ammonia is also same. Okay. So let's say this is from where we are producing the ammonia, and this is where we are collecting it. So we have to ensure that we have a inverted funnel. So if you have an inverted funnel, then what happens is first whatever ammonia is produced will trickle down all the locations of the funnel, and only then it will start, the absorption process will start. So dissolving process will start. But if we don't have the inverted funnel, then what will be caused is the back suction. So this is to prevent back suction. To prevent back suction, we use inverted, we use inverted funnel. So this is how we create the aqueous solution of ammonia. Now let us look at a few properties of ammonia. So what are the properties of ammonia? First is, if you look at the properties, it is colorless. The gas is colorless. It has a pungent choking smell. Pungent choking smell. What else? It has got it is very highly soluble in water. It is highly soluble in water. Anything else? It is lighter than air. This also we have seen, that is one of the methods for collection of ammonia also, by downward displacement of air. So if we talk about the solubility of water, then there is again another experiment for this, and that is this experiment for checking the high solubility of water is also called as the fountain experiment. So this was also discussed, if you remember, in the HCl gas and HCl acid recording session. So here in this experiment, what we do, we take an inverted uh, round bottom flask and we fill it with ammonia, and we connect it to a dropper. One will be connected to a dropper on one side, and on the other side we'll have a jet tube, which is like a you can say it is like capillary tube, and this flask